and I'm here to talk about an open source project called Pattern. Just to give you a little bit of background, I have a dual background, so to speak, both in the quantitative side, math, stats, et cetera, as well as in computer science in distributed systems. And over the past 10 years, I've been leading data teams to build out very large-scale apps. But more recently, I've been working at Concurrent more as a domain expert, subject matter expert, in terms of understanding the apps that are being built with an open source project called Cascading, as well as a couple other related open source projects, or actually a few other related open source projects, Scalding, Cascalog, et cetera. So I'd like to give a little bit of background about Cascading first, and then go into, this talk here is largely about PMML and our implementation of PMML for big data workflows. And from there, we'll talk a bit about what you can do with this kind of technology, and also some of the more advanced patterns, such as working with ensembles. And from there, I'll talk a bit about a general kind of enterprise app that we're seeing across a lot of the use cases. So Cascading is actually, let me check first. How many people have used Cascading? OK, excellent. Well, that's a lot of people here. Cascading came from about 5 years ago, going on 6 years. Chris Wenzel is the author, and at the time, he was a system architect at Thomson. He was evaluating some of the open source tools that were coming out of the Nudge project. So this was, say, actually talking about here, this was like circa 2005, before Hadoop really even had a name. And of course, Nudge produced Lucene for indexing, as well as Nudge, as well as eventually Hadoop. And Chris was taking a look at these to evaluate how could these technologies be used in an enterprise context. And the takeaway was, especially with respect to Hadoop, that it would be very difficult to find a lot of Java developers who could go and write directly to MapReduce API. That's a specialized skill set, and even today, of course, it's hard to find people that are very expert at writing Hadoop jobs directly. So a key insight there is that if you look at MapReduce, if you go back to the original papers where they were talking about it at Google, it really does have a lot of aspects of functional programming. And Chris Sievers was actually giving a talk a little bit earlier here today discussing about different types of abstractions in Scala language, again, along these lines of functional programming. But the history of MapReduce, it really goes back to what the AI community was doing in the 70s and 80s in Lisp at places like MIT, Stanford, CMU. I got in the game as a grad student in AI in Stanford in the early 80s. And the other point, too, is that when you look at use cases on Apache Hadoop, the non-trivial use cases are typically some kind of data pipeline, which are functional in nature. So an idea for the origins of Cascading were if you could take and implement this idea of data pipelines and some aspects of functional programming inside of Java. And that was introduced in late 2007. It's really, there's a twofold purpose there. On one hand, you're leveraging a lot of existing Java technology that's already in enterprise. You go to most enterprise shops, they have very tight tooling on their JVM apps, and they've invested a lot of money in that. On the other hand, they probably have a lot of people who are very adept at writing code in Java. So this puts Hadoop into the hands of people who write Java all day, every day. Formally speaking, Cascading is a pattern language. So let me check about that. How many people have worked with pattern languages before? A few. OK. Don't get me started, because I love this concept. A pattern language, we'll go drill into this a little bit further, but it came from architecture. It came from Chris Alexander and the Oregon experiment. And the idea is that by using the syntax of the language, you can have some guarantees of best practices. In this case, parallelism for the pipelines when they're running at scale. Let's see. Cascading is a Java API, but there are DSLs in Scala and Clojure, as well as other languages. It's Apache 2 license. All the source code is up on GitHub. And there's a Maven repo called Conjars, which is where a lot of the third-party contribs And the other thing is there have been a lot of different types of verticals. We've seen 5 years and more of enterprise deployments. As far as partnerships, we're working with most all of the different Hadoop distributions, different cloud vendors, et cetera. There's tight integration with Memcache, Cassandra, different types of data frameworks, because at the end of the day, when you're writing large-scale Hadoop apps, Hadoop is rarely used in isolation. It's almost always used with something else. You're almost always bringing your data from some other place, some other framework, like, say, Cassandra or S3, and then you're pushing your results out to some other kind of framework to be served, like, Memcache or MySQL or MongoDB. As far as case studies, we've got a pretty rich set of those. You know, early on, the first uses were mostly around ETL, bringing in log files, doing roll-ups on log files. But that evolved over time. We saw more and more market funnel analytics. We saw more anti-fraud classifiers. And more recently, we're actually seeing this move away from what I would term as e-commerce, moving out into more real-world Internet of Things kinds of applications. So we're seeing very large-scale applications on cascading for next-generation gene sequencing, climatology, agronomics, power grid, balancing, a lot of location services, et cetera. So the 4 points there about using something like cascading are, number one, being able to put Hadoop technology in the hands of people who write Java code, or Scala code, Clojure code, et cetera. Number two, it's about system integration. It's about being a kind of middleware. And then number three, closely related, is how do you reduce the complexity of moving apps into operations? And number four, it's about being able to leverage some of the aspects of functional programming to provide a flavor of test-driven development when you're working with very large-scale apps, very big data. I'll give an example of that later. I'm an O Reilly author. I've got a book coming out now called Enterprise Data Workflows with Cascading. And it's largely about this notion of workflow abstraction. It's about how can you do your business logic at the app layer and then have the compilers take care of the details underneath in terms of scheduling Hadoop jobs. So to give an example of an enterprise data workflow, here's a kind of a generalized use case. Typically speaking, the front end, the line of business use cases, that's what drives the need for doing big data apps. But also typically in enterprise, organizations have made a lot of investment in their back office systems. So the infrastructure that they have and the people who are trained to be expert in using the different tools in the back office. And you need to integrate with that if you want to be able to leverage Hadoop for these kind of mainstream firms. But yet we see these mainstream firms doing a lot of the heavy lifting now with Hadoop, moving a lot of workloads out onto Hadoop clusters. So in terms of workflow and abstraction, cascading defines something called a tap. And a tap is a formal way to integrate with another data framework. So for instance, there's a tap to connect up to HBase, or a tap to connect up to Cassandra. The interesting thing is that by having that formal description, something the compiler sees and knows about, you end up getting, number one, a lot of information about schema flowing through your app, and also about data lineage when you have this in practice. So taps are pretty easy. I show here a very short word count program, and there's a couple of lines to set up the input and output taps. And then down at the bottom, I connect those into my application graph and run it. There's another notion of something called a topology. So Hadoop is a kind of distributed topology for computation. But there's a lot of others. And one of the things about cascading is it separates the business logic of what you're doing with your app from what the compiler works with to actually implement that into jobs. So the top part of it is where people are working with business logic. The bottom part is what the compiler is doing, the planners, et cetera. What that means is it's not necessarily tied to Hadoop. We could do other kinds of topologies, other types of planners. So we've done one for local mode. We have another one in progress for doing in-memory data grids, probably doing some kind of integration with things like Titan or Spark would also be really good for planners. And as far as swapping out different topologies, it's pretty quick. There's just a few lines of code. What I'm showing here is how to set up a Hadoop flow connector for Hadoop topology, and then down at the bottom, how to execute it. Okay, so I mentioned about test-driven development. One thing that's really interesting about cascading is this notion of test-driven development where you assert patterns that you expect to see in the data. So you've got these data pipelines, and you have tuples that are flowing through the pipelines. And you can assert functions at any point. So think about it. If you start out with your raw data, and you think of the first chunk of processing that you have in your pipeline, then put an assert statement right after that processing, defining what you expect to see in the data after that processing completes. And then go run it and make sure it fails, because it's test-driven development, and then code until it stops failing. And then you move on to the next chunk of processing, assert, verify that it fails, code until it doesn't. By the time that you move through your whole graph of your application, you've got your application plus full test coverage. And the nice thing is that you can also turn off the assertion levels, basically like log4j, turning off the log levels. So if you want to assert things very strictly while you're in development, but then maybe turn them off in production, you could do that. Another way is that the exceptional data that gets trapped out when it fails an assertion can be shunted off. So maybe, if you're running through a lot of customer records and something fails in assert, you might want to shunt that data off to operations for a notification. Or you might want to send it to finance for an audit, or maybe customer support for some kind of elevating a ticket. Okay, so pattern language for workflows. The idea is that we're working with pipes, so we have this metaphor of plumbing and a lot of things you would hear about in plumbing in terms of sinks and taps and filters. If you've done plumbing, this will be a breeze. Pattern language, though, comes out of architecture, Chris Alexander and others. And the idea was being able to convey expertise through syntax. So a really simple analogy for that would be kiddos working with Lego blocks. If a kiddo is going to build up a tower out of a set of Lego blocks, when you snap the blocks together correctly, you have some guarantees of structural stability, how the tower will stand. If you don't snap the blocks together, it'll probably fall over. And so there's a similar way of leveraging pattern language for programming. When you have the parts of the API fit together, then you have some guarantees of how the compiler can parallelize it when you go to compile. Another thing is that by working with these pipelines, you end up with graphs. These are directed acyclic graphs. And there's a very visual representation. Actually, when you go to plan a cascading job, one of the steps in the planner generates a dot file, generates the actual graph of what query is going to be executed out on the Hadoop cluster. And so that's a kind of literate programming, going back to Don Knuth. And the notion there is, rather than spending your time telling the computer what to do step by step, spend your time telling other people what you want the computers to do. Another way of saying that is really capturing the business logic, the business process. So that's what we're trying to do with cascading. What it works out to is a kind of separation of concerns. At the high level, you've got your business process, your literate programming, and then by virtue of having the pattern language, that gives you guarantees that the compiler would be able to handle it and do some very parallel processing underneath. And how many people have ever read the original paper on relational model from Edgar Codd? Good, excellent. Okay, I love this paper, it's great. This is one from 1970, not the original IBM paper. But Codd is an interesting person. He wasn't exactly the biggest fan of SQL, but he wasn't really arguing about the relative merits of structured data versus unstructured data. Rather, he was arguing about the process of structuring data, that an application is actually about the process of structuring data. And actually, Codd is the animal on the O Reilly book about cascading. That was a very nice thing that worked out. Okay, so proof is in the pudding. Cascading set out to implement flavors of functional programming inside of Java. And other companies have gone out and built open source projects on top of cascading and invested a lot of capital and time into that. So Twitter, eBay, LinkedIn, et cetera. In particular, Cascalog and Scalding are two of the most popular. And these companies have in turn built their revenue apps in those open source projects. So we think of cascading almost as assembly language programming for functional data pipelines. There's a great article about that by Dan Woods out of Forbes recently. Okay, so to try to illustrate this, if you look at word count, if you look at a very good Hive implementation of word count and actually worked with the authors of the Hive book to get this code as tight as possible. So it's about 52 lines of HQL, and then there's a UDF that does a function in Python. If you were to implement that in Scalding, it works out to be about a third that size. It's really interesting. There's a lot of reduction in code volume when you leverage the functional aspects of data pipelines. Now, I go out and I talk to a lot of different customers. I work with a lot of developers in the community. I'm trying to evangelize open source technology, but I'm also trying to understand the use cases and do a lot of analysis of the use cases. And what we see is that there's this graph. I've shown it in 2D here, where there's like complexity versus scale. It's really 3D. It should be complexity versus scale versus innovation. And what happens is there's really two avenues to success. There's the enterprise incumbents, and the enterprise people have to deal with complexity all day, every day. And they've typically made very large investments in terms of infrastructure, in terms of Java, SQL, SAS, and the people trained to work with that. And so if you're going to introduce Hadoop into enterprise, you have to embrace those technologies and the skills of those people. On the other hand, you've got startups which are trying to go after the incumbents, and they really crave complexity to try to become viable. And so we're seeing that whereas enterprise uses Java a lot, we're seeing that the startups going into enterprise space tend to use more of the functional languages like Cascalog and Scalding. But what's interesting is that when they get it right, both sides meet in the middle. When you're working with innovation versus complexity versus scale, there's kind of a middle point if you get it right. Okay, so that's some background about cascading. Let me talk about PMML. There's an XML standard that's been around since 1997, so 15 years or so, 16 years. And a lot of activity. In fact, there was press releases from FICO and Zementis this morning, I think, about PMML. There's a lot of members, a lot of support. It's a very rich kind of definition of workflows for predictive models, and it's based in XML. It doesn't execute anything. It captures the model. As far as coverage for different types of modeling, there's a lot of what you would typically use. Perhaps not everything, but it's certainly a very large set. And some of these here are actually families of algorithms. And they can be mixed and matched. You can do ensembles, and you can do chaining. You can throw in a lot of models on a given implementation. As far as the kind of coverage that you see for PMML, it's pretty much everybody and their brother and sister and pets. The idea is that, SAS, SPSS, we hear this over and over when we go into enterprise shops. That's what they're using for modeling. Probably some R, probably some MATLAB, but pretty much all of the different analytics vendors are supporting the ability to create a model, but then capture it as PMML for export. So that's good. That's a way of providing a very convenient kind of integration between what the shops are doing with their predictive analytics and what kind of capabilities we're introducing now with Hadoop. So when was this? I guess late last year, we started on this project called Pattern. And the idea was to be able to migrate workloads off of SAS and Teradata, SPSS, to be able to run them directly on Hadoop without the analysts having to do any coding. And it applies as well for R. My teams usually do a lot of work with R, MATLAB, things like that. But what's nice is that what this means is you can take and capture your predictive model as PMML, but then drop it into a much more complex workflow, which may have a lot of other elements, a lot of other data preparation or other kinds of algorithms developed out of libraries. In Chris Siever's talk earlier today, there was discussion about algebra, for instance. There's a wealth of libraries that have been implemented for Scalding and for Cascalog, and they're great to be able to leverage with this. So as an example, I wrote an R script here, which, okay, let's imagine that we've got some customer orders coming through here as a data set. What it does is to train a random forest on a label. So let's say that this is a anti-fraud classifier written in R. And I'm using random forest, and basically we create the model, we show what kind of lift it has. And then down at the very bottom, it's just one line that says save the PMML file. And the PMML file looks, well, this is what it looks like. I don't recommend that humans read this ever. My team has had to do a lot of reading on this. But this is what computers are for. Now, to use this in code, it's really only a few lines. Down here, we have a string variable that references the location of the PMML file. And then we have a class called a PMML planner, which takes that PMML file and creates an assembly of pipelines to fit into the cascading data pipeline. And that's it. And what's interesting is that there's nothing here that says this is a random forest, or this is a linear regression, or this is support vectors. It's just a PMML file that's being handled to it. So when it comes to the coding, the data engineers doing the coding, the application developers, they don't need to know details about modeling at all. That's encapsulated in the XML, in the PMML. And what that also means is that then you could build a lot of different models and just run them from command line on Hadoop. And in fact, that's been a lot of the early use cases. This is a flow diagram for a cascading app that ships with the pattern project. It's up on GitHub. And so you can just build this and run it. You can run PMML right out of the box without having to write any code. And there's some Hadoop command lines for that. OK, so as far as the roadmap, we've implemented a number of different algorithms. In fact, there's, at last count, about 6 different companies that are collaborating to implement these algorithms and more. There's also a lot of support in the API for model chaining, for assemblies, more complex combinations of models. We've got a few things on the fire right now as far as other algorithms that are being implemented. Time series and A-rules are probably the 2 most that I hear about. Neural nets as well. But there's a user group. There's a Google email group, pattern-user. So if you want to get involved, you want to find out more about what's going on, I definitely recommend checking out that user group. Now, in addition to taking PMML and scoring models, what's also interesting is the ability to create models at scale. And the idea there is, if you create your data pipeline to ingest your data and do your data preparation, cleaning up your data so that you can present it to train a model, then you can think of that part of the pipeline as being code that could be reused in production for actually scoring the model. So work in progress right now is to be able to leverage pattern to train models at scale on Hadoop, capture the models as PMML, and then be able to run them. OK. Now, what was interesting is when we first went out and started talking to customers about how they might use pattern, customer experiments was the thing that we heard over and over. And as it turns out, this is what's being used in production. I used to work at a company called ImView, which was, if you've read a book called Lean Startup, it was based on ImView. And we're really big on customer experiments. So that was one of the first things that came to mind for me is how could you take and run a lot of different models using PMML, basically capturing a PMML file for each different model, and then leverage Hadoop to be able to do your experiments, basically do your comparisons between models to find out which ones are better. A/B testing, multi-arm bandit, et cetera. So as an example, if I take my, my sample customer orders and I train a random forest, here's what R tells me as far as out-of-bag estimate on error rates for random forest. And I'll take the same data and I'll train a logistic regression. And now, just to accentuate the difference, I actually threw out one of the variables for the logistic regression. I'm not trying to harsh on logistic regression. I have some feelings there, but I just want to show that one of these models is better than the other. So what I can do with pattern now is to run both those models and capture a confusion matrix for each one. And so this will tell me what are the number of false negatives, the number of false positives off of each model. And in the context of anti-fraud, that's really interesting. When you're working with fraud, typically there's a trade-off. If you get false negatives, then you're in trouble with the bank. You know, Visa and the others, they're going to give you more risk in terms of chargebacks. And if you have too many chargebacks, you go over 1%, they shut you down. On the other hand, if you have too many false positives, then you get in trouble with your customers. And so now you've got a lot of customer support cost, and you have to staff up your call center. So when you're writing anti-fraud classifiers, you're perpetually going back and forth on, you know, these curves of what's your cost of chargebacks versus your cost of customer support. In this case here, we were able to show that logistic regression, even though it had a lower false negative cost, which meant that less trouble with the bank, it had a higher rate of false positives, which means that we would be just paying money out the nose in terms of customer support. So you can think of this is two models being compared. You could actually come up with a matrix of comparing hundreds of them if you wanted to. And actually, that's what some of our customers have been doing. Alrighty, so now another thing that's really interesting is if you can compare different models, and if you can combine different models together using PMML and pattern, this opens a few doors. There's an excellent paper that I reference in almost every lecture called The Two Cultures by Leo Bremen. How many people have ever read this? Okay, one of my favorites. It basically described what was happening in the late 90s, going into the early 2000s, when we first saw success from Amazon and others. It's really some of the origins, I consider, the origins of data science, when we moved away from doing data modeling and started looking at using very large-scale data to do algorithmic modeling. And of course, Bremen was very much into ensembles and random forest. The reason for this is when you work with data that perhaps has hundreds of millions of customers, one of the first things you're going to encounter is that there's not a given pattern for success. There are a number of different patterns that you have to address. So we have this problem of customer segmentation. When you're doing marketing, there's typically a few different important customer segments that you must address. And when you're doing your models, you have to not just work with one bell curve, okay? You want to try and hit some different modes. And we see this borne out in terms of, for instance, the Netflix prize. When you looked at the winners of the Netflix prize, you know, going down to the last stages of the competitions, there would be hundreds of different predictive models being used by one of the leading teams. And then as they got closer and closer, the actual teams combined into being these sort of super ensembles. So there's some great papers about that, actually, about the multiplicity of data models. And Todd Holloway and Lester McKay in particular have had some really good discussion of what to do with ensembles. Of course, statisticians have been using ensembles for years and years. This is old hat. But being able to represent it in terms of Java and XML and all, it's kind of a new thing, especially on Hadoop. There's a paper, Girish was one of the other developers who created some of the language, some of the algorithms in Pattern, and Girish and I had a paper accepted for KDD this summer, talking about using Pattern and Hadoop for ensembles. Now, the reason why we've been doing this, the practical reason for doing this, is that as I'm going out and talking to very large companies, which are embracing Hadoop, embracing big data and data science, as I'm talking with these companies, I'm seeing a design pattern for an enterprise app, for the batch apps. And I'm finding it hard to identify use cases which don't fit this yet. I'd love to find more. But the general pattern is this, is that you've got different data sources. You can think of having some structured data, some unstructured data, et cetera, coming from different directions, HBase, Cassandra, relational, et cetera. You go through some ETL process, loading up your data into a common place to work with, like HDFS. You apply some secret sauce, some business logic that's custom for your business to do your data preparation. And then once your data is cleaned up, you present it to your predictive models, your analytics. You get your results and you push those out to the end use cases. So typically in enterprise, people are using ANSI SQL, one flavor or another, for ETL. And it's SQL, it's not necessarily relational. It's SQL for data which probably is never going to be indexed, probably never going to be normalized, but SQL is capturing the business logic. And then for the data preparation, of course, there's Java, there's Pig, there's others. For the modeling, people use SAS, SPSS, Microstrategy, R, et cetera. So what we notice is that the licensing costs are predominantly either in the ETL or in the modeling. You know, basically what you're seeing with SAS, in particular on the modeling side. But yet the project cost, the people cost, is primarily in the data preparation. So in my projects and my peers' projects, we have this kind of Pareto relationship where 80% of the cost for a given project is just preparing the data over and over. That's people cost. So what we did was to say, in the context of cascading and other types of open source built on top of it, like Cascalog and Scalding, we have very formal ways to integrate with the data sources, the taps. We have a way of taking ANSI SQL and parsing that, generating assemblies to fit into the pipeline. Of course, we have ways of doing data preparation. That's what people have been using cascading for a long time. Now with Pattern, we have a way of taking models from SAS and SPSS, et cetera, and parsing those and creating assemblies to fit into the pipeline. And then the end use cases, the results get pushed out into Memcache or HBase or something. So the compiler gets to see the entire thing. It's one app. It may be generated from 3 or 4 or 5 different departments, but all of those work products go into one application, one directed acyclic graph. The compiler sees that, can optimize across that, can do exception handling and troubleshooting across that entire graph, and notifications. And it all gets compiled down to one jar file. So now, even though you're a director of engineering at large company XYZ, and you have 5 different departments working on these mission-critical apps, at the end of the day, operations sees this as one jar file to run on the Hadoop cluster. And that's a very powerful thing. So to show real quick, on the SQL side, you have an assembly planner that just basically takes the SQL as a parameter. On the analytics side, you've got a PMML planner that takes the PMML file as a parameter. And you tie them together. Here's, for instance, the kind of sample app that I was showing there. You've got a visual representation. Now you've got a good way of tying these different teams together and their business logic. Okay, so multiple departments. That's the theme of what we're trying to do with this app layer, with this workflow abstraction, this middleware for Hadoop. Okay, so there's a book that's actually in print right now. It's Enterprise Data Workflows with Cascading. It's supposed to be out in July. And there's some newsletter updates if you want to keep track of that. I want to give some acknowledgments. A lot of different people have really helped out on Pattern. Girish is here today, Chris, Ofer, and a lot of other folks who are far, far away have contributed on this, and really appreciate working with them. Also, as far as cascading, as far as our developer community, there's a lot of links here about our events and different projects. And let me know. I'll be here for some questions. We have a little bit of time, and I'll be outside later on. Thank you very much. Any questions?
So with the clustering algorithms that you've already implemented, do you have the ability for me to essentially create my own cluster dissimilarity methods?
That's a good point. Can we do a plug-in there on that? We were implementing what's in PMML if you're just reading the PMML, but the other side of that is that with Pattern, you don't have to use PMML. It's a way of basically parsing PMML to implement the workflows. If you want to go directly to the Java classes, you can do that. And certainly, then, yes, you can override functions and operators inside of cascading.
OK. And then one other one. For your hierarchical clustering, What type of linkages do you have implemented?
The simplest possible.
Okay, single.
Yeah, no, for hierarchical, we didn't go too far and too long on that, but I'd love to talk to you if there's specific use cases we could do. It's basically being driven by use cases at this point.
Yes, for generating the PMML, on the pre-processing step, do you create PMML or you create Hadoop jobs? Because the PMML 4.1 is a lot of pre-processing.
Yeah, the pre-processing is interesting because in PMML, you've got this preamble that shows your metadata, or what your tuples look like, what your scheme is for your tuples. And you can do some pre-processing on that. You can do model chaining, so you could run a model and then have some intermediate variables, do some processing on then, go to a different model, and do some post-processing. So all of that goes down into cascading calls, and it goes into the jar file.
Okay, thanks.
Does it work with Scalding?
Yes. So the thing there is that with pattern, with PMML, what we're doing currently is to generate an assembly. And so if you're familiar with cascading, there's a notion of a cascade where you take different flows and put them in. In this case, you would have PMML as a flow and then a cascade for your general application. So in that case, yes, it's JVM classes that could be called out of Scalding. It might be the case that you would, well, it depends. I haven't done it yet in Scalding, but I have been looking on the Cascalog side. And in that case, it might be simpler to actually compile your flows down into a jar file and then build a fat jar for which your cascade would reference.
Okay.
Yes.
So when you're running the PML model for the scoring, what's the parallelism abstraction? How are you?
That's a really good point, is that, I mean, PMML is capturing the model. It doesn't really say how to execute. So in cascading, we do have the opportunity to do parallelism, depending on the algorithm, in different dimensions. For instance, if it's random forest, do you hand a different tree to every mapper, and then do something with a reducer or something smart? That's really left up to the implementation at this point, but we've tried to provide a lot of different building blocks and try to do that as smart as we can. Frankly, a lot of the algorithms, like clusters, it's map side. It's going to be pretty quick. Mm-hmm. But when you get into more interesting ensembles, then you actually have different phases, map, reduce, map, reduce. So far, that's been left up to the people who implement the individual algorithms. Any other questions?
So for your random forest implementation, are you going to be able to build one tree over many nodes, or is it going to be like capacitated at a tree per node?
You mean for the scoring side or for training side? Training side. Training side. Training side, we haven't, that's still in progress. So we're trying to consider that. There are, I'm going to get in trouble here because I don't have the paper in front of me, but there has been some recent work on doing fairly parallel ways of training random forests, in which case we could distribute it. We'll see about that, but that'll be coming up pretty soon.
When is this all coming out?
Well, we already have it in production for the scoring part, for the parts that I said were implemented. So there's like 8 different algorithms that are implemented. The training part is something that we're currently working on, and there's a couple of people in particular who are helping out on that. So I definitely recommend checking out the email list because the developers are active on there. That's where we're coordinating.
It sounds like this is basically replacing Mahout. Would you consider that to be a fair statement?
I'm glad you asked that. I was hoping somebody would ask that. No, I started out looking at Mahout and wanting to use it. And Mahout has excellent implementations for certain algorithms, and it's very good to use. There's some difficulty in terms of how to integrate Mahout with other applications. The driving factor here was, A, I wanted to build out a lot of machine learning libraries with cascading, possibly using Mahout, Mallet, and others. B, we wanted to capture a lot of metrics about cascading apps to feedback so that the people working on the APIs and cascading could optimize them, especially for large-scale machine learning apps. So we were really trying to collect data about the applications. And we started in trying to implement random forest out of Mahout. There's definitely some great documentation on that online, but I started looking around and I realized that PMML was going to be a much shorter path So I did that implementation instead. And then once we got into it and started talking to customers, they were like, oh yeah, PMML, let's do that, let's do all of them. So it really came out of the notion of trying to optimize cascading, but then it evolved into being PMML. I think that I don't want to displace Mahout, but this is more about how you leverage the functional aspects, the flow planners for parallelism, which with Mahout you can't do.
So what's your plan on supporting cascading on top of Yarn? Is that something you guys are working on, or?
Yeah, definitely we're talking. I would definitely work with Hortonworks, and working with Hortonworks in particular off pattern. This will be the last question because I've got to go. So there really shouldn't be any problem, is the short answer. This is something that runs on top of Hadoop, and ostensibly it could run on other topologies as well. That'll be interesting, is like, do we move beyond MapReduce into other types of topologies? But there shouldn't be any problem with running it on Yarn if you can run cascading on Hadoop there. Thank you very much.